Next proof number 7. If the quadratic equation ax square plus bx plus c is equal to 0, where a comma b comma c belongs to R, so here a, b, c are constants and they are real numbers. So a, b, c belongs to R. R means set of real numbers. Is having real roots. Here quadratic equation is having real roots. So those roots are alpha and beta. Real roots alpha and beta. And if the roots are in the ratio, so here alpha and beta are in the ratio of m is to n. M is to n. Then prove that m plus n whole square into AC is equal to mn b square. Then prove that m plus n whole square is into AC is equal to mn b square. So we have to prove this formula, okay, this relation. Okay, so here given one quadratic equation, there is a quadratic equation. So what is the general form of quadratic equation? General form of quadratic equation is ax square plus bx plus c is equal to 0. Here a, b, c are belongs to our real numbers, and this quadratic equation is having real roots alpha and beta. So alpha and beta are in the ratio m is to n. So here alpha comma beta are the roots of quadratic equation ax square plus bx plus c, and they are in the ratio m is to n, means m by n. They are in the ratio alpha by beta is equal to m by n. Okay, just transpose beta, you will get alpha is equal to m by n, division becomes multiplication into beta. Now we need to prove this. M plus n whole square into AC is equal to mn b square. Anyhow, let us consider common ratio be x. Here alpha and beta are in the ratio m is to n. So let us consider, let common ratio be some let us say some k. So common ratio be k. So if common ratio is k, then alpha is equal to, what is the value of alpha? Alpha is equal to mk and beta is equal to nk. So if common ratio is n, then alpha value is mk and beta value is nk. Mk and nk. Okay. So in case of quadratic equations, sum of the roots. What is the formula for sum of the roots? In case of quadratic equation, sum of the roots means alpha plus beta is equal to minus coefficient of x by coefficient of x square. Coefficient of x by coefficient of x square. Minus coefficient of x by coefficient of x square. This is sum of the roots formula. Sum of the roots alpha plus beta is equal to minus coefficient of x. So coefficient of x. So here quadratic equation is ax square plus bx plus c is equal to 0. Here coefficient of x is b. So minus b by. So here coefficient of x square is a. So minus b by a. What is the value of alpha? Here value of alpha is mk plus value of beta is nk. So mk plus nk is equal to minus b by a. Simplify further. So what is the common thing here? Here common factor is k. Take out k and the remaining terms m plus n is equal to minus b by a. Minus b by a. Next. So next. Similarly, we have one more formula in quadratic equations, product of the roots. Product of the roots. Product of the roots. Product of the roots means alpha into beta. So alpha into beta is equal to, what is the formula? Constant term by constant term by coefficient of x square, constant term by coefficient of x square. This is product of the roots formula. Product of the roots is equal to alpha beta is equal to constant term by coefficient of x square. Let it be equation number 1. Product of the roots is equals to constant term by coefficient of x. Constant term in ax square plus bx plus c is equal to 0. Constant term is c by coefficient of x square is what? A. Again product of the roots. So here alpha how much? Alpha is equal to mk into beta is equal to nk is equal to c by a. So mn k square, m into n mn, k into k square is equal to c by a is equal to c by a. Let it be equation number 2. Just look at equation 1 and equation 2. From equation 1, k is equal to transpose m plus n, multiplication becomes division, then k is equal to minus b by a into multiplication becomes division, so m plus n goes to the denominator, 1 by m plus n, 1 by m plus n. K is equal to minus b by a into 1 by m plus n. Okay, so we got k is equal to minus b by a into 1 by m plus n. So name this equation as 3. This is equation number 3. From now observe equation 2 and equation 3. In both the equations, what is the common thing here? Common thing is k. Okay, so anyhow here we should eliminate k. So what is the value of k here? Minus b by into 1 by m plus n. So substitute equation 3 in equation 2, equation 3 in equation 2. So here, suppose here I want to eliminate k. Okay, so just replace k by minus b by a into 1 by m plus n. Okay, so put k is equal to mn into, put k is equal to minus b by a into 1 by m plus n whole square, mn into k square is equal to c by a, mn into minus b whole square you will get plus b square by a square into 1 square 1 by m plus n whole square. Apply square to all the terms is equal to c by a. Okay, now transpose m plus n whole square, a square into m plus n whole square to right hand side, division becomes multiplication. Here mn b square is equal to c by a into a square into m plus n whole square, a get cancelled. Now mn b square is equal to a into c, ac into m plus n whole square. So let us rewrite this as m plus n whole square into ac is equal to mn b square. So this is the final equation. Hence, okay now, if quadratic equation ax square plus bx plus c is equal to 0, having roots alpha comma beta and alpha comma beta are in the ratio m is to n, then m plus n whole square into ac is equal to mn b square. Okay na? This is the procedure to prove this relation.